All right, 5.2. We're going to talk about properties of exponents and radicals. So we're continuing with what we did in 5.1, but we're just going to talk more about our exponents and radicals. So we've talked about all of these before in our pre-chapter stuff. It's just going to be a little bit different now, but same stuff. So when we're multiplying two numbers that have the same base, what do we do to the exponents? Add them. So we knew that from before. If we have a power raised to a power, an exponent raised to an exponent, what do we do to that? Multiply them. If I have two numbers that are being multiplied to the same exponent, we distribute it to both. So it'd be like a to the nth power and b to the nth power. What does a negative exponent do? Flip it. So it'd be 1 over whatever our value is. What is anything to the power of 0?
0. Oh, 1.
1. What do I do if I'm dividing two numbers with the same base? What do I do to the exponents? Subtract. So when we're dividing, we subtract. And then in the last one is the same thing. If we have two numbers that are being divided to the same exponent, we can distribute the exponents of both the numbers. So it'd be a to the nth power divided by b to the nth power. So this page is super helpful, especially for the homework. It would help if you have any question that looks like this or looks like this. Like all the questions in the homework are going to look something like one of these, but just have different numbers. So this will kind of give you a hint on what to do. You just have to use the different numbers from the homework. So I think this page with all the examples is very helpful. All right, so let's look at example 1. So A, they have the same base and I'm multiplying. What do I do to the exponents? Add them. Our favorite fraction. So I have 7 to the power of 1/4 plus 1/2. What do I need in order to add fractions together? Common denominator. How can I make these have a common denominator? Perfect. I can multiply the 1/2 times 2 over 2. So times 2 and times 2. That would make this 2 over 4, sorry. 2 over 4. So now I'm adding 1/4 plus 2/4. So what would that give me? 3/4. So 7 to the power of 3/4. That would be my answer. Let's look at the next one. No, you can just leave it with the exponent. For the next one, can I combine these together? No, because they have different bases. But what can I do? I can distribute the 2. So I'm distributing the 2 to both of these exponents. What do I do to when I have a power raised to a power now? Multiply. So my first one, what is 1/2 times 2? 2 over 2, which is just 1. So it would be 6 to the power of 1, which is just 6. So remember, when we are multiplying fractions, we multiply the tops together and multiply the bottoms together. So in the second one, this would be 4 to what power? The 2/3 power. Perfect. So this would be our answer. So the 2 just gets distributed to the exponent. All right, let's look at the next one. What could I do here? Distribute the negative 1/5. So this would be 4 to the power of 5 to the power of negative 1/5 times 3 to the power of 5 to the power of negative 1/5. What do I do when I have a power raised to a power? Multiply. So I could make this 5 over 1, multiply the tops together, and multiply the bottoms together. So what's 5 times negative 1/5? Negative 1. So this would be 4 to the power of negative 1. Same thing here. What's 5 times negative 1/5? So it would be 3 to the power of negative 1. Perfect. Can I simplify this anymore? How? I flipped them. So it would be 1 over 4 times 1 over 3. Can I multiply these together? Well, the exponent then turns positive, but we wouldn't say 4 to the power of 1. It just kind of goes away if it's just 1. But typically, if it was any other number, if this was 4 to the power of negative 2, it would be 4 to the power of 2. It just turns positive when you flip it. What can I do next? Multiply them together. So multiplying fractions, we multiply the tops together and multiply the bottoms together. So this would be 1 over 12. All right, let's look at the next one. So these have the same base. So I can combine them together. What am I doing here? Dividing. So what do I do to the exponents when I'm dividing? Subtract. Well, what's my exponent on this 5? 1. So it'd be 1 minus 1/3. Again, we have fractions. What do I need when I'm subtracting fractions? Common denominator. So what can I do to the 1 to make it have a denominator of 3? Multiply the top and the bottom by 3. So it would change to 3 over 3. And when I subtract, what do I get? So 5 to the power of 2/3. It would be the same as if I had, let's say, 5 squared divided by 5. Well, we can work this out by subtracting the exponents, bless you, which would be 2 minus 1, so that would be 5 to the first power. Or if you actually did 5 squared, it would be 25 over 5, which is 5. So if you were to multiply out the top, then you would divide. But you just subtract the exponents. Don't do anything with the number, it just stays there. All right, next let's look at E. A couple different ways we could do this. What do you think I should do first? I can distribute the 2. So this would be, what do I do when I have a power raised to a power? Multiply. So 42 to what power? To the 2/3 power over 6 to the 2/3 power. Now these have the same exponent. I can combine them together to be 42 over 6 to the 2/3 power. Now we would want to simplify the fraction. So it's 42 divided by 6. 7. So 7 to the 2/3 power. So if I wanted to do that in the first step, I could have changed it to 42 over 6 to the power of 1/3 to the power of 2, and then multiplied these together and divided on the inside, which is the same. They're probably the equal amount of steps too. It just depends on what you want to do first. Let's look at number 1. What should I do first for number 1? For number 1? I'm multiplying, so what do I do to the exponents? Add them. So this would be 2 to the power of 3/4 plus 1/2. So the base stays the same, we just add the exponents together. Now I have fractions. What do I need in order to add fractions? A common denominator. So what could I change 1/2 to be? 2/4, perfect. I just multiplied the top and the bottom by 2. Now we can add these together. So I get 2 to the power of what? 5/4, perfect. All right, let's look at number 2. I'm dividing here. So I subtract the exponents. What's my exponent on the top? 1. So this would be 3 to the power of 1 minus 1/4. So what do I do to subtract here? Need a common denominator. So what could I change 1 to be? 4 over 4. Perfect. And when we subtract, what do we get? 3/4. So 3 to the power of 3/4. Because remember, we subtract the tops and keep the denominator the same. Let's look at number 3. What could I do first for number 3? Distribute. We can distribute. So it'd be 20. What do I do when I have a power raised to a power? Multiply. So 20 to what power? To the 3/2. So 3 over 2 over 5 to what power? 3 over 2. Can I simplify this even more? How? Perfect. I can make it 20 over 5 to the power of 3 over 2. And what's 20 divided by 5? 4. So 4 to the power of 3/2. What could I do for number 4? Distribute the 3. Perfect. So this would be 5 to the power of 1/3 to the power of 3 times 7 to the power of 1/4 to the power of 3. Could I have combined the 5 and the 7 together? No. They have different bases, so we can't add the exponents there. I just can distribute the 3. So what do I do now when I have a power raised to a power? Multiply. So what's 1/3 times 3? 3 over 3, which is 1. So it'd be 5 to the power of 1, which is just 5. Times 7 to what power? 3/4. Perfect. If you want, make it a fraction, then multiply the tops together, multiply the bottoms together. This would be our answer. 3 over 3, which was 1. We wouldn't write 5 to the first power. All right, on the next page. So we have similar properties when dealing with radicals. So remember, we can go from an exponent to a radical just because let's say I had 5 to the 1/2 power. What's my index? 2. The denominator is the index. So that's what we learned in 5.1, is that we can go from an exponent to a radical based off of the denominator, which would be our index. So we have similar properties. The product property, we can split up. If I had two numbers being multiplied under the same radical, I could split it up into 2 different radicals, but it would have the same index. So if I had the cubed root of 4 times the cubed root of 2, that would be the cubed root of 8. So I can multiply the insides together, only when it's the same index. Same thing with division. You can split it up into 2 different ones or combine them together. So if I had the 4th root of 162 divided by the 4th root of 2, it would be the 4th root of 162 divided by 2. So you can just combine them under the same one when they have the same index. All right, so example 2a. What can I do here when I'm multiplying them? I can multiply 12 times 18. So this is the 3rd root of 12 times 18. Now our goal is to simplify. So do you think I actually have to multiply 12 and 18 together? No, because I'm going to break it down to find the factors anyways. So I might as well just find the factors from here. What are 2 factors of 12? 6 and 2. And 2 factors of 6? 3 and 2. 2 factors of 18? 2 and 9, and 2 would be 2. 2 factors of 9? 3 and 3. How many of a kind do I need to circle here? 3 of a kind. Do I have 3 of a kind? What? I have 3 2s and 3 3s. So what comes to the outside? A 2 times 3. Because I had a group of 2s and a group of 3s. Did anything have to stay on the inside? No, because everything got circled. If something didn't get circled, if it didn't have a pair, it would just stay on the inside. And 2 times 3 is 6. So my answer here is 6. So from the beginning, I couldn't figure out what the cubed root of 12 is, I can't simplify that. I can't simplify the cubed root of 18. But when you're multiplying them together, put them under the same radical and then simplify. Let's look at B. What should I do first for B? All right, so what could I do first for B? I can combine them together under the same one. So the 4th root of 80 over 5. Can I divide 80 by 5? So this would be the 4th root of 16. Perfect. Let's see if we can simplify this. What are 2 factors of 16? 4 and 4. And 2 factors of 4? 2 and 2. I'm circling groups of how many? Do I have a group of 4? So what comes to the outside? 2. So my answer would be 2. And we can get rid of the radical because we have nothing left underneath. So our answer is just the whole number 2. So on this slide, it talks about when a radical is in simplest form, it has to meet these conditions. So no radicans have a perfect nth root as factors other than 1. So that's just saying under our radical, like if I had the cubed root of 8, I would have to break this down and simplify. So this can be simplified. What's the cubed root of 8? 2. That's a pretty common one that we see often. No radicans contain fractions. So if I had like the square root of 10 over 2, I would have to simplify that. Then you would have to break it apart into 2, and then we'd have to get rid of the denominator, which we'll see on the next page. So this would be the square root of 5. And it says no radicals can appear in the denominator of a fraction. So this one is super important. To meet the last 2 conditions, we have to rationalize the denominator by multiplying the expression by an appropriate form of 1 that eliminates the radical from the denominator. So we rationalized in the past when we did the pre-chapter stuff. So we're bringing it back. So we're going to be rationalizing to get rid of the square root from our denominator. So rationalizing gets rid of the radical in the denominator. Okay, let's look at example 3. So we have to write each expression in simplest form. So for A, I have to simplify the cubed root of 135. What are 2 factors of 135? 3 and 45. Perfect. What are 2 factors of 45? 5 and 9. 2 factors of 9? 3 and 3. I can circle how many of a kind here? 3. So 3 3s get circled. What comes to the outside? 3. It takes it to be a pair, a circle, to come to the outside. What has to stay on the inside? The 5. The 5 doesn't have a pair. So I keep the same radical. It has to be the 3rd root, bless you, of 5. So this would be my answer. So anything that doesn't have a pair has to stay on the inside, and it has to keep the same radical with the same index. All right, let's look at B. So Arden, this is one of those where you can't simplify the fraction if we put it together. So what I would need to do is figure out my factors of 8, whatever's in my denominator, because that'll help me figure out what I need to multiply to rationalize. So what are factors of 8? 2 times 4, and 2 factors of 4? 2 and 2. So how many 2's do I have? 3. How many do I need to make this a whole number? 5. I need a group of 5. So what I need to do is multiply the top and the bottom, because whatever we do to the bottom, we also have to do it to the top. The 5th root, because it has to have the same radical. So the fifth root. And how many more 2's do we need to make this a whole number?
2.
We need 2 more 2's. So what's 2 times 2? 4. So I have to multiply the top and the bottom by the same radical, but the inside has to be 4 because it has to give me a group of 5. So why we have to multiply it by the fifth root of 4 is because we need a set of 5 in order to make this a whole number. I have 3 of them, so how many more do I need to make this a set of 5? 2. And what's 2 times 2? 4. Because when we break this apart, so if you want to, you can write it together under the same radical. So that would be the fifth root of 8 times 4 on the bottom. Does everybody see what I did there? What would the top become? So the fifth root of 28, perfect. Because we keep the radical but multiply the inside parts together. So that gave us 28. We can, but my goal is to get rid of the radical down here. So we're going to break it apart now because we know that we have enough 2's here. So 8 we know broke down into 3 2's and 4 is 2 2's. Do I have a group of 5 now? Yes. So what does the fifth root of 8 times 4 simplify to? 2. So now I have 2 in my denominator and the fifth root of 28 on the top. That would be my answer. We could try to simplify this fifth root of 28, but what are factors of 28? So I'm going to do it up top here. So it'd be 7 and 4, which would be 7. Do I have a group of 5 here? So can I simplify this at all? No. So our whole goal was to rationalize and get the square root from out of the denominator. So all we needed to worry about was making the denominator a perfect root so we can make it a whole number. So here we had to rationalize, which means that we get rid of the radical from the denominator. So you can't have a radical in your denominator, so once we get rid of it, that's our answer. All right, so as an extra one, we're going to do 26. So it was the cubed root of 7 over 4. So I could break this apart as the cubed root of 7 over the cubed root of 4. Now we have to rationalize. We can't leave that radical in the denominator. We have to rationalize. Bless you. So 4 would break down into what times what? 2 and 2. I need a group of how many? I need a group of 3. So how many more 2's do I need? 1. So I'm going to multiply the top and the bottom, because it has to be the same on the top and the bottom, by the cubed root of 2, because I just need 1 more 2 to complete that perfect radical there. Whatever we multiply to the bottom, we also have to multiply it to the top. So our goal is to just make the bottom a whole number. We don't really care what the top is, but whatever we multiply to the bottom, we have to do it to the top. So now that I have 3 2's, what does the bottom turn into? 2. And what would the top be? Awesome. The cubed root of 14, because I multiply the 2 inside parts together, and the radical part stays the same.